To understand the diffraction, we should understand the Huygens principle. What is Huygens principle? Why we have to be introduced this Huygens principle? Okay, according to the actually Newton's corpusculus theory, light propagates in a straight line direction. That means a rectilinear propagation. And light is a continuous stream of tiny, that means very small particles, elastic particles traveling with the speed of the light. This Newton's corpusculus theory explains the properties of the light. Reflection means when the light rays are incident on a smooth surface, they will rebound. That is reflection. And refraction, when the light rays are traveling from one medium to the another medium, at the interface the light will bend. That is refraction. This reflection and refraction both are successfully explained with the theory of Newton's. But this Newton's theory failed to explain some of the concepts. That means multiple colors we are observing in a thin films. Why we are observing? The Newton's theory didn't explain. That means interference didn't explain by the Newton's corpusculus theory. Why we are observing the shadow regions? The shadow regions means diffraction patterns. It was also not explained by Newton's corpusculus theory. To overcome those failures, to explain that, Huygens introduced one theory. That theory is also called as uh, Huygens wave theory. According to the Huygens wave theory, what he was proposed that uh, light is a wave and it explains the diffraction and also the interference. This propagation of light is explained by considering the wave in the form of a wavefront. In the form of a wavefront. So how the wavefront is generated? The wavefront is, for example, if we take this one as a source, this one is a source. From this source, the light is exhibiting particles in all the directions, with the same velocity, That means after time t seconds, if we observe those positions, if we observe, so those are traveled from the center is equal distance. That means if we take this one as a two dimensional, it is a curved surface. Sorry, it is a circle. But if we take this one as a three dimensional, it gives like a spherical. Okay. According to him, each point, each point on the primary wavefront. What is primary wavefront? This is called as primary wavefront. This is called as primary wavefront. How it can generate it? So when the particles are executing or traveling in all the directions, that means the disturbance is traveling in all the directions at a particular instant. If we take their positions and draw the sphere, that gives the primary wavefront. This is primary wavefront can generate once again the wavelets like this when it strikes anything. So these are called as secondary wavelets. These secondary wavelets is also continuously generating the light waves. Due to this, the light is propagating. So new position of the wavefront at any instant, which is called as a secondary wavefront. That means this is a primary wavefront and this is a secondary wavefront. A point source of light, eminent light waves in all directions, The wavefront corresponding to the light source can be thought as a spherical surface. So this can be considered as a spherical surface. And this spherical surface, if it is travels very long distances, it can be converted into a plane wavefront. It can be converted into a plane wavefront. This is also called as spherical cylindrical wavefront or plane wavefront. Like this, simply one point here remember, that is, if we take a source, from the source the particles are traveling in all the directions at a particular instant. If we observe, or if you draw the line, that is also called as primary wavefront. That means the primary wavefront consists of large number of tiny particles. These tiny particles are generating the secondary wavelets or secondary wavelets. These are traveling very long distances. Nearby the source, the wavefront is either maybe spherical or cylindrical. When it is traveling very long distances, that is converted into a plane wavefront. This is a plane wavefront, this is plane wavefront, and this is spherical wavefront. This is spherical wavefront. This Huygens wave theory successfully explained the interference and also the diffraction. Okay, thank you.